So today I'm going to talk about inner development loop with Java on Kubernetes. I work as a software architect at Systematic in Aarhus. In particular, I work on healthcare-related projects. I'm really passionate about anything Java, Spring, Cloud Native. I also wrote a book about that. It's called Cloud Native Spring in Action. And I'm a big supporter of open source technologies. I like contributing whenever I can to Java and Spring-related projects, but also in general to Cloud Native projects. So, inner development loop. What does it mean? Well, we are talking about here about how, as developers, we approach the development of a new feature or perhaps fixing a bug. So if you think about what you do when you sit down at your desk and you have to implement this new feature, exciting feature to deliver to your customers, we have a first phase where we code something, perhaps using test-driven development. We implement this new feature. Eventually, we want to run the application and test that everything is as we expect it to be, and if necessary, even do some debugging. Now, all these activities, we repeat them continuously. It's a loop. It's a loop that we implement locally in order to do our development work. And the reason why I'm talking about inner development loop is that depending on how we approach this loop, how we implement it, the technologies we use, the processes we use to build a new feature, or the organization we have around us, then there is an effect on our experience as developers. And that's what we call developer experience. Now, I think after the last couple of years, we can say that developer experience is one of the new buzzwords in our field. And I really don't like buzzwords. I like to define words and be sure that everyone agrees on a common meaning. And developer experience is nothing new, even if now you hear a lot talking about that. And my favorite definition comes from a research paper from two engineers from the University of Helsinki. And what they write about developer experience is that it can be defined as a means for capturing how developers think and feel about their activities within their working environments. Think and feel. And why is that important? It's important because we imply that an improvement of the developer experience has positive impacts on characteristics such as sustained team and project performance. I really like this definition because there's nothing about technology here. It's even about feelings as developers. Think about working in a very noisy environment. You're trying to focus, but there's a lot of noise in your room. Your IDE is showing all red lines because it can't find your third-party dependencies, and suddenly Dogger crashes, it doesn't work, and it gets so much frustrating. How many of you can relate to this? I mean, sometimes it's just too much. We want to focus on the business logic. We want to provide value, but we are impeded. We get frustrated, and ultimately, what we're talking about here is the delivery of value. So if we can improve the developer experience, automatically we can improve the way we deliver value. We deliver higher value to our customers, to our business, and as developers, we feel better. So feelings are also important here, because I'm much more comfortable working when everything in my environment works fine, and I can focus on solving the problem that I'm trying to solve in that moment. The problem with developer experience, as we usually talk about nowadays, is that we focus a lot on tools. But tools are not enough. And in the definition, there was nothing about tools. Besides using technology to solve this problem, we also need to have in place the right processes and right practices that can support the usage of that technology. And ultimately, we need the right organization surrounding us and supporting us in what we are doing, supporting those processes, having people educated to support those processes. Ultimately, developer experience is a culture. And we can apply this model, I really like it, because we can apply this to so many things. Think about security. Security, all right, I buy this product for security, that's the technology circle, I'm done. No, because then in the organizational circle, there's an employee that doesn't know about email scams and then click on a link and then suddenly ransomware spread out in your organization. Technology is not enough. Or think about microservices. Oh, it's great with the cloud, we get all this great technology available. We just click a button, we have everything we could possibly imagine. Yeah, right, but if your processes are wrong, if you are not shaping up your teams and your organization to work with self-autonomous, independent teams with well-defined boundaries around your microservices, that will not work. And how many cases we heard about migrations to microservices failing? And that's because of this, because we too much focus on the technology circle. But if organization and processes don't catch up, then whatever we are doing fail. Technology is not enough. Now, having said that, today I'm going to talk about technology a lot. And I'm going to showcase different tools, and they can really help with your developer experience. But I have to warn you that just using these tools will not solve the entire problem. You also need the right processes and the right organization around these tools. So don't try them by themselves and then think that the problem is solved. Yes. So technologies are in place. We're going to talk about those specifically. I won't talk much about processes and organization, but what are the goals? What are we trying to achieve here? First of all, I want to achieve a rapid and continuous feedback loop as a developer. I want to do that while also having reduced cognitive load. I don't want to learn 20 new things that are not related to the problem I'm solving within my application. And also I would like the solution to be part of a clear path to production. We can't solve the problem on the developer environment without considering the rest, without considering the whole path to production. And we start with a baseline, with a cloud native application. So without Kubernetes, without containers, let's see what's an initial way of shaping up this developer experience. And then from there, we're going to see all the challenges that we get when we go to Kubernetes, and how can we mitigate those and solve some of them. So I'm going to use a Spring Boot application, but this really works with any Java application, and in general, whatever the application language or framework you're using, these concepts are still applicable. I have here a very simple Spring Boot application. It's a web application. I have a main method where I initialize the application, and then I expose an API. I have two endpoints, the root endpoint, return a welcome message, and the books endpoint that returns a list of books. And the book is a record. So let's give it a try. I've run the application. I'm running it locally on my JVM. So what I can do now here is testing that it works. I'm running on port 8080. So let's try the root endpoint. Perfect. And the books endpoint. And it works. So at this point, I want to add a new book to the list. So let's do that. Let's all add the Silmarillion book. All right. Now, what is happening under the hood is that the application is doing a live reload. So it realizes that something changed, and I don't have to do anything. But if I call the endpoint again, the book is there now. So my Spring Boot application keeps running and monitoring for changes. So if I do a change again, because the book is actually titled The Silmarillion, and I save, then you can see that the application realizes that there have been modifications in the class path, and the application is automatically reloaded. Let's give it a try. Perfect. So this is a quite nice inner development loop. We get a very fast feedback loop. I can run the application once at the beginning of my session, and I don't have to touch it anymore because it's continuously reloaded. I can debug it. I can test that everything works. And it's just great. This will be our baseline of a good developer experience. And if we look a bit at the history before cloud native applications, we started with traditional applications where we would have still a runtime environment, like the Java virtual machine. We would have a middleware, like an application server. We would have the application packaged as WAR file or EAR file. And now, with cloud native applications, we work directly on the runtime, and the applications are self-contained. So we package them as jar artifacts. They're executable jar files. They don't have any external dependency except the Java runtime environment. And we improved a lot the developer experience, because in the traditional model, the feedback loop was quite slow. We improved it a lot. And if we consider also the cognitive load, it's actually getting smaller with cloud native applications because we don't have the burden also as developers to run and maintain this application server locally when we are working on new features or fixing bugs. So all is good, but then came containers. And things started getting a bit more challenging. So of course containers are great. They were, with Docker especially, a real game changer in our industry. But that also meant that developers got additional tasks now, because now your application cannot be a jar artifact anymore, it should be a container. So what do? We write a Docker file. And then perhaps we go online and we find out how to do that. And we come up with something like this. Very simple Docker file. Like this, where we are basing the image on the OpenJDK version 17 from the Temurin distribution. We are uploading the jar artifact that we had from the Cloud Native application, and then we are running it. That's great. It works. It's fine. Writing Docker files is simple. However, writing Docker files for production is definitely not simple. Like, this is not production ready. I don't want this in production. So I started looking into it and I realized that performance is really not good. Putting jar files like this one inside an image is actually an anti-pattern. What I want to do is expand the jar files and distribute all the classes into layers. And Spring Boot also helps with that, because I can extract the jar files and put different layers with different classes, so that if I'm changing my own code, I don't have to rebuild and put in the image also all the third-party dependencies. That doesn't make sense. This helps not only locally to speed up my feedback loop, but it also helps in production, because it means that we are only, when we do a rolling upgrade, we only have to download a small layer. So if you're in the public cloud and you're paying for how much data you're using, that's also how you can optimize your costs there. But then you read that Docker is not secure because it runs containers in root mode. So we have to do something about that. New iteration. Let's run the process in a non-root user. And this continue going on and on in trying to optimize this Docker file. And it's not even stopping there, because once we have the first version, then we have to maintain it. And since this will be in our application source code, it means that developers will be responsible for it. And that's not really nice, because what we are talking about here is that we have moved from application servers to cloud native, and that was good. But now we get more time in our feedback loop, because we also have to add this step to build the container image. And then we added more cognitive load. We have the Docker files. So one thing we can do in order to at least reduce the amount of this extra cognitive load that we get as developers is using something like Cloud Native Buildpacks. It's a specification. It's hosted at the Cloud Native Computing Foundation. And what it does is that it converts your source code into container images that are production ready without running a Docker file. So it works. It's a polyglot tool. It works for different languages and frameworks. So actually, it's not just for Spring Boot or just for Java, but you can use it with your Go application or .NET. And whatever you have as input, it figures out how to better containerize that source code, taking into account security, compliance policies, performance, and the output is a container image that you can use in production. One way to use Cloud Native Buildpacks is to use its own CLI. It's called pack. So I can say pack build and then point to my source code. But when using Spring Boot, that's actually integrated within Spring Boot itself, both for Gradle and Maven. So if I go to the source code again, let's move to this other folder here and open the terminal. Now I can do, let me put this up. I can do Gradle boot build image. And I get a container image out of it, which is great. We reduce the cognitive load. I don't have to write a Docker file, and I get something that is more production ready without having too much to consider that myself. And that's great. So for a while, maybe we are fine. We start running things on Docker. Things get still a bit slower compared to before, but overall, at least if we can get rid of the Docker file maintenance, yeah, I'm quite happy about it. But then comes Kubernetes. And now things get really, really complicated. Because once again, application servers, we improve things a lot with Cloud Native, and in the Java ecosystem, we have great modern frameworks to work with Cloud Native applications. Things got a little worse with containers, but now with Kubernetes, what we have is a runtime environment that is a container runtime. We have a middleware again. That's Kubernetes. We went back to having a middleware. We have our container, and once again, our feedback loop got slow. So it looks like we didn't improve a lot. And if you look at the cognitive load, it became even worse than how we started compared to how things were with application servers. So wait a second, there's something wrong here. So why is everyone moving to Kubernetes if this is the picture? Like, this looks very, very bad. Well, Kubernetes, of course, provides a lot of benefits. So if you have a use case for it, you start moving to Kubernetes, but usually that is driven more from an operational point of view about deployment, about orchestration. And too often, we forget about developers. So we improve things to standardized deployments. We have now a secure environment. Kubernetes is the operating system of the cloud, cloud agnostic. It's really great, but then we forget about developers. Because usually the discussion is after a developer push changes to a Git repository. What about before that? What about the developer work to produce value, to deliver that value to customers? And of course, we have to look into that. That's why developer experience in the last couple of years became so important in the cloud native space. Because suddenly we realized, oh wait, developers are there too. So what can we do there? We can use Tilt. So let's move back to the code. We can achieve a container image using Buildpacks. Then we have the burden of creating some Kubernetes configuration files. For example, I won't go too much into detail to this. This can also be auto-generated, actually, a deployment object that we want to create in order to tell Kubernetes how to deploy our application. We need a service object to expose the application inside the cluster. And we need an ingress so that from outside the cluster, we can access the application. So if we had to do all these things manually, every time we make a change, we have to compile the application, we have to build a container image, we have to push that container image inside the cluster, and then we have to apply this manifest to the cluster so that the application is deployed. And that would be over and over again. And suddenly our feedback loop is just so slow and we get so frustrated about this. The developer experience is really bad. With Tilt, we can automate all these steps and achieve that continuous development approach that we had initially with our baseline when working with plain cloud native applications. So what I can do here, I have a Tilt file that I use to configure Tilt. There it is. So it's actually quite straightforward because we are telling Tilt to use the command that we would use manually. Use Gradle boot build image to build an image. We want to enable the live update feature that I showcased earlier. And then we are pointing Tilt to our manifest for the application in order to deploy it on Kubernetes. And also we are asking Tilt, please expose the application to my local machine so I can access it through localhost. And if you ever work with a Docker Compose, this would feel very natural because I can just say Tilt up. And that Tilt takes care of the rest. Compile the application, containerize it, deploy it, and keep monitoring my code so that every change is automatically reflected in the cluster. And on top of that, we even get a nice GUI interface. Let me zoom in a bit. So we have the book service here. And what is happening now under the hood is actually those steps that I would do manually on my local machine. When that is done, I can access the application. And after that, I can forget about it. I run tilt up, and then I keep working on my application like I did initially, without Docker and without Kubernetes. So there it is, my application is running. We can give it a try. It's exposed through 8080. I have that. So let's try to change that and see how it's reflected inside the cluster without having to do anything manually. So I go here. Let's change the message. So I heard that they're taking the hub is to Isengard. Yes. We can see that in the GUI, file changed have been detected. So if I call the application again, there it is. So I'm running inside a container that is deployed on a Kubernetes cluster. But as a developer, I'm getting the same exact experience I get when I work without those technologies. So instead of running Gradle boot run, for example, or running the jar file, I'm running tilt up. But the experience is very comparable. So I'm a bit less worried about that with tilt. Still not good, but let's move on. We have this. There's actually another tool, it's called Skaffold, that works in a similar way. It doesn't have a GUI, but you can check it out if you want to use that. It's slightly different in a way that you configure it, because tilt uses Python. With Skaffold, you would have to use YAML to configure Skaffold. So yeah, both can give you this continuous deployment flow. But so far, I've been talking about trying to achieve this feedback loop on top of Kubernetes directly from my machine. However, there are other options. There is a tool called Telepresence that lets me basically create a bridge from my local machine to a cluster. By doing this, I have a cluster where my entire system is running, and then in my local machine, I have my application running as standard Java application on my JVM. And with Telepresence, what happens is that every time my application is called, it's actually going through the cluster. So there's a proxy every time my application is called. Instead of going to the instance running in the cluster, it goes to my local machine. So this is useful both for feature development, but it's also useful in case of debugging and troubleshooting, because you can connect to whatever cluster you have, perhaps in a test environment or staging environment, and just redirect the traffic for the one application you're working with, for example, book service in my case, and then work locally without having Docker or Kubernetes installed anywhere. You would just run on the JVM on your local machine. So having said that, if we go back to the goals we had at the beginning, we kind of addressed the first goal. We have a quite fast iteration loop, fast feedback loop as developers using Tilt or Skaffold. We have reduced the amount of cognitive load. We don't have a Docker file, but still we have at least 3 Kubernetes manifests. That's a lot of YAML. Even if we generate them automatically, still we have to maintain them. And then how are they related to the whole path to production? So that's why I want to talk about Knative now. Now, Knative is a project also hosted at the Cloud Native Computing Foundation to build, to extend Kubernetes and build platforms on top of Kubernetes. Among the other things, it provides serverless capabilities. So if you want to work with serverless and functions, Knative does that on top of Kubernetes. It provides event-driven capabilities. So if you do data streaming, you can use Knative as well. That's not possible in plain Kubernetes. And for developers, it's helpful because it exposes more user-friendly or developer-friendly abstractions. I want to mention here Kelsey Hightower because he defines Knative in a very nice way. He wrote in a tweet last year that if Kubernetes is the electrical grid, then Knative is its light switch. And I think that's really great and really captures what is Knative. And I mean, it's probably the first thing I install on any cluster. I don't want to interact directly with Kubernetes. I want to work with Knative. And I'll show you why. Because now I can get those 3 manifests I had before. First, let me do a tilt down. That's how you stop your continuous deployment loop here. And if I move to Knative, I deleted all those manifests, and now I have one single manifest. It's much simpler. As a developer, I have to point to an image, I have to expose my container port, and I can add some additional configuration that is actually not required. The only thing required is the image. And I can do it from the CLI as well. So I'll move to a different cluster now, and I'm gonna show that. All right, so I can say KN, that's the CLI from Knative, service create, the name of the service, book service, KN, and then the image. So I have previously pushed an image on my GitHub container registry, and I think it's called this. All right. So what is happening now is that that file that I showed earlier is automatically generated. And you can see from the CLI that this actually resembles a lot the Docker CLI. It's even easier because you don't have to specify the port if you're using a standard port, so you don't have to expose it explicitly. And there it is. Not only it's deployed, not only it's exposed within the cluster, not only is exposed outside the cluster, but I even get a very convenient and nice URL that now I can use to call the application. And you can do that too because it's on the public internet. So I send an HTTP request, and there it is. Welcome to the book service. So as a developer, I'm happy about that. Nice. Yes. Now, at this point, we talked a lot about what happens on our local environment when we work. But in some companies, you might be adopting some processes requiring you to open a pull request and requiring someone to manually test the code in the pull request before being able to deliver that. Now, that depending on the process, it might also be a problem that we need to address and solve in this vision about developer experience. That's also part of it. Because if it becomes very difficult in order to get our feature out there, then we are really slowing down the pace that we have, the flow that we have to deliver value. Because as long as our changes are not in production, they are useless. They don't deliver any value. So of course we want to go to production faster. And if we have a pull request-based process in order to deliver a new feature, we want to automate that as well. And one way of doing that is using ArgoCD. Now, ArgoCD, you might have heard of it because you can do continuous deployment with it using a GitOps approach. But there's a very nice feature that is not that much known that lets you configure some temporary environment provisioning so that whenever you create a pull request, automatically you get a temporary environment in Kubernetes with your application deployed. So let me show you what I mean. I have here a repository. It's called music service, the application. And I have my current branch where I'm developing new feature. You can see that this is one commit ahead of the main branch. So now what I can do is open a pull request. I create the pull request. Then maybe I have some colleagues looking at the pull request and reviewing that. But in the meantime, I also want a tester to manually test the new functionality. Well, if I look in Argo, there it is, in a couple of seconds. A new environment has been provisioned automatically in a new namespace called GOTO CPH, that is the name of my branch. The application is running, is exposed, and adopting all the nice features I have in the cluster that I also use in production. So I have also this environment parity. My colleagues can have a look, I can have a look as well. And when I'm done, if I merge the pull request or I close the pull request, perhaps I want to reject it because in this case I just changed the README file and that was a very not useful change. So let's say I want to close it. No, that will not go in production. I close the pull request, and what happens is that ArgoCD will unprovision the environment automatically. It's temporary. We don't want it to stick around, especially if we are in the public cloud that we pay a lot of money to deploy applications. We really want this feature there. We don't want containers that are hanging around in the cluster just consuming our money. All right. So if we go ahead and review the goals that we have addressed so far, the first goal, rapid and continuous feedback loop, I must say that I'm quite okay with using Tilt and not having to do all those steps manually myself. I'm not that okay with the cognitive load. I don't have to maintain Docker files, I don't have to maintain Kubernetes manifest, but still, even if I'm using Knative, I have too much responsibilities on my side as a developer. And then I still can't see this clear path to production, because once we have our manifest in our Git repository, then what happens in production? Probably we need to change the configuration, we need to integrate it and bind it with external services, for example. All of that is missing. So how can we interact also with other colleagues in different teams in our project in order to achieve that? Configuration management, we really don't need it locally, and we don't want to deal with it locally. I don't want maybe to use Helm locally. That's something additional. Really like Carvel for configuration management, it provides Kubernetes native package management options. But again, as a Kubernetes enthusiast or Cloud Native enthusiast, I really like that. I like working with it. But if I'm sitting on my desk working on a feature, I don't want to hear any of that. I just want to focus on delivering value on my feature. Even if I like those tools, I like those technologies, and I'm aware of where my application will be deployed eventually. That's important in general as a developer, right? We want to know the constraints of the environment where we are deploying our applications. That's an important info when we clarify and design our solutions. If we don't know the constraints of the environment, then probably our design will not be that good. But what I want to do as a developer, take all these tools and remove them all. Maybe I'm fine with keeping Tilt. That I'm okay with. And then introduce a platform. And of course, I'm not dealing with the platform myself as a developer, but maybe in my team there's going to be a platform team offering a platform as a service to me as a developer, to my team as a product team. And all those tools will actually be responsibility of the platform team to configure, to maintain, and to keep them running. And then we need some kind of interface. And what we like as developers is a self-service API. If I have to open a Jira ticket to get some service, that is not the cloud, even if it's on the cloud. Like Jira ticket and the cloud are opposite things. I want a self-service API. I click a button, I send a command, and I want something provisioned for me automatically. So we kind of need this way of calling or consuming the services provided by the platform. And also within the platform itself, we need a way to combine all these tools. Like the platform team needs a way to glue them all together and offer to us as developers a very nice experience. There are different ways of doing that. One way that I'm going to talk about is using Cartographer. Cartographer is a very nice tool for doing this. So you can see that now Tilt is going to interact with the platform via Cartographer. And then what happens in the platform is responsibility of the platform team. So instead of using Cloud Native Buildpacks directly on our local machine, even if it's easy, perhaps with Spring Boot it's built in, then all of that is moved to the platform. So locally, I don't have to build a container image, I don't have to deal with manifest, configuration, ArgoCD, all of that will be part of the platform. And Cartographer offers this framework to build, they're called golden paths to production. So as a platform, like I want as a developer a platform that offers me a very easy way to go to production. And the concept of golden path is that the platform can offer some paved path or pre-approved path to go to production based on what you're working with. Perhaps we have a golden path for web application, one for functions, one for event-driven applications. And the amount of information or cognitive load for developers is extremely low. Let's have a look at that. So now I have a cluster with the platform installed. Like all these tools are glued together with Cartographer. All right. So if we go back to the application, I even deleted the Knative manifest. Now, I don't need to run Docker locally to build a container image. That's done inside the cluster. That's also an additional benefit. But I have introduced something new here. This is the API, the contract that we have between developers and the platform. It's called a workload in Cartographer. And in the workload, we can specify what kind of golden path we want to consume from the platform. In this case, it's a web application. And then I define information that only me as a developer know about this, because it's special to my current application. That is the Git URL. This is where to find the source code for my application. I can provide additional configuration if I wanted to. I don't need to, but perhaps about me using Java 17 or resource limits and requests on the container, that is not needed. The only thing that is needed is the Git URL. This workload is used both locally when I do my feedback loop, but also across the value chain until production, until we get to production. So let me show you this. No, one folder up. So I still have tilt. I have a tilt file configuration that now is using the workload file instead of calling boot build image and my manifest. And I can say tilt up again. Now it would look like, after running this, that everything looks the same as before, but nothing is happening on my machine now. Everything happens in the cluster. And if we look in the cluster, I can see that my application is running there. It's even running with HTTPS. I get certificate provisioned automatically for every application I'm running. So if I send the request, we can see that it's there. Welcome to Isengard. Let's try the feedback loop, right? So I go to the application, Java class, welcome to Isengard, yeah. And save. Now everything is reloaded. You still get the GUI, by the way. I'm not using that now, but no, now. I have from Visual Studio Code here a nice link to that. Yeah, it's not shown here. Anyway, so we still have the GUI. I can follow all the process there, but let's see how fast it is. And it's not that fast, but I can show you what is happening under the hood. I have a lot of those actions that before were running on my machine, now they're running in the cluster. Now, I won't go too much into detail here, but the main information is the source code that is coming from my local machine, and it is continuously refreshed. I have this supply chain configuration. This is my golden path to production, where my image is built using KPack, which is a Kubernetes native implementation of Cloud Native Buildpacks. I have a convention service. This is quite interesting because since the platform can tell that my application is a Spring Boot application, it applies automatically all Spring Boot specific configuration, like exposing the actuator endpoints, enabling the graceful shutdown. All of that is done automatically. I don't have to do that. If you have a Go application, then the conventions will be different. So this is what we call an application-aware platform. And then finally, the URL. So we're still using Knative, and I get HTTPS as well. All right. So we did all of this for improving our experience as developers, of course. But as I said, this is all about delivering value better and faster, from code to production. So we talked a lot about the developer experience with this, how we interact with this path to production, specifically the inner development loop. But once we go and move to this model where we have a platform offering to developers a self-service API and a lot of services out of the box, then we also achieve not only reduced cognitive load, but separation of concerns. Because now application operators can provide their expertise and apply their skills to the path to production, to the platform. Security experts, same thing. If I build my container image locally, how can the security expert in my company make sure that I'm compliant with all the company policies? You can't do that, because that's distributed across thousands of Git repositories. But now we have one single place where we can do this. And now the path to production that I showed, that's not specific to my application. I can create whatever application I want in Spring Boot. And just by using that label, this is the web golden path, then the whole chain will be the same. So it's a reusable thing. So you can quickly bootstrap new applications without having any additional cost from that point of view. You don't have to set up new pipelines. You don't have to set up new environments. The platform takes care of that. And finally, of course, we have platform engineers that glue all these tools together, are responsible for maintaining them. But it's really nice to have this clear separation of concerns. These are not necessarily different people. I'm more talking about them as personas. But it's important to have this distinction and clear responsibility. Also, for me, like working with different hats, when I'm wearing the developer hat, I just want to focus on what I'm doing, like the new feature I'm working on. Even if I know about Kubernetes, I don't want to deal with Kubernetes directly when I'm building a new feature. If I'm wearing the Cloud Native enthusiast hat, I'm all for it. Yeah, let's play Kubernetes, but not when I'm building features. Yes. One thing I want to show you is that once we have this golden path, we can define some templates. So for example, on Spring Boot, on GitHub, I have a golden path for Spring Boot web applications. So every time I want to build a new web application, I use this template here, create a new repository, and I get automatically that cartographer configuration. You can see here, we have the workload file. And even better than this, in a platform, now it's very common to use Backstage. This developer portal solution, it's open source, it's been built by Spotify. You have a very nice user interface, graphical user interface, with the concept of golden path built in. That's something that comes from Spotify. So we can even improve further the developer experience here. Yes, so we went through these three main goals. I focused a lot on technologies, as I mentioned earlier, but let's not forget about the other two circles. Just as reference for the organization part, I really recommend the Team Topologies book that helps you define and design organization to achieve this fast flow. So the concept of platform team, product team, that is called streamline team, and how they should collaborate between each other. That's an important part. No Jira ticket. That's not the cloud, that's not a good developer experience, we want something better. So if you're interested into that, I recommend reading this book. Regarding processes, to quote Dave Farley, like, we know no better engineering practice than continuous delivery to build better software faster. So continuous delivery is always actual, always current book, always valuable. And next to that, I can also recommend the DevOps Handbook and the Accelerate Handbook about how to deal with that part, the circle about processes and practices. Because without that, these technologies will not work.